All right, hello, Algebra 1. Here's what I got. This is section 1.4, and this is your notes for it. This is on absolute value equations, which will be intimidating to look at first because you got these bars and you're like, what the heck is going on here? But it's actually pretty easy math and not much different from what you've already done. Know that after 1.4, I have 1.5 for you, which we'll do the next day that we meet. And that's the end for chapter 1. Okay, so once we're done with 1.4 and 1.5, I don't have anything new from that chapter. We'll take another quiz on 1.4 and 1.5, and then we're done with that chapter. Okay, so this will go quick, our week will go quick, and we'll be done with this before you know it. Okay? All right, here's what I got. Absolute value bars. Here's what they do. It's more easy to explain this way. Let me just put these bars in, and I'm going to write a little -2 in here. And here's what it does. It makes your number in the inside positive. Okay, makes it positive. So absolute value of -2 is 2. Absolute value of -80 is 80. So if it's a negative sign in here, it just makes everything positive. If it's already positive to begin with, like 6, then you just keep it positive. Okay, you don't change the sign, you just make it positive. All right, so some people say, is it an opposite? Well, it's only an opposite if it's negative to begin with. Okay, but if it's already positive, then you just keep it as is. Okay, and if you ever have a 0, it's just 0. And that's it. Okay, so here's what I'm asking. You're like, hey, what can you put in for x so that in the end, if you're to do this math, your answer is like a 10. All right, so most people instinctively say, you know what, if I just put a 10 there, yeah, the absolute value of 10 is 10. So yeah, 10 is a good answer. However, it could also be equal to the opposite of this. It could be equal to -10, right? Because if you take a bar and put -10 in, it becomes a positive. All right, and it's that simple. All you're gonna do is take this x that's in this bar, whatever's in this bar, and set it equal to the answer piece, and then the negative version of that answer piece. All right, so here's what I got. Here's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll put a dot there. And I'll go 10 the other direction. Put a dot there. And we're done. Easy, not so bad, all right? Same idea. This guy must be positive, okay? So x minus 1 has to be equal to 4, just like I did this. This x is equal to 10. And this is a huge and, these problems always have two parts. I'm gonna say x minus 1 is equal to the opposite of this. Okay, so notice I set this 10 equal to a -10. That was the second piece. Same thing over here. I'm going to set equal to a -4. Okay, and then you always have that. There's always those two parts. All right, so now we're going to solve. I'm going to add 1 to both sides. And 4 plus 1 is 5. And then if I added 1 over here, this one's going to be the same rule. Okay, and then -4 plus 1 is -3. So here's 0. Okay, there's my 2 dots. And you are done. Okay. One thing to notice is that whenever you subtract up here, it's like you have subtract 1. 1 is that halfway split. Like, do I have to know that? Not really. Not for now, at least. But you will in the future. All right. So again, always 2 answers. There's 1. There's 2. I'm going to do this one next. You're like, why? Why are we skipping this one? Because it's difference. All right. Same idea. I got to set x minus 4 equal to 6. And I'm also going to set it equal to -6. All right, there's always 2 parts. You always set it equal to the positive version of this and then the negative version. Don't change the sign in here. Okay, don't make that addition sign. Leave this alone. Okay. All right, so here's what I'm going to do. I'm going to add 4 and add 4. And that will give me 10. The opposite of subtract 4 with the x is add 4. And I'm going to add 4 here and add 4 here. And negative 6 plus 4 is negative 2. All right, so again, here is 0. Negative 2 is to the left. And positive 10 is way out here. I'll put a dot on each one of those. And again, not that you have to know this for now, but what am I subtracting in the absolute value bars for? Well, there's 4. That's the halfway spot between those two. All right, so that leaves us with 1 left. And again, I've said this in other videos. If what I did was a little fast, stop it and rewind it, okay? It's okay to do. My little boy does that, and he's an elementary school kid, all right? His teacher does this on virtual classrooms too, just like you are. And again, he's got a teacher who does it, kind of like what I do, but he's much younger. And he'll go through it, and I'm like, oh, that's too fast. He'll just backtrack it, and that's okay to do, okay? Go at your pace. All right, last thing. Remember our rule, absolute values. These guys have to be positive. Must be positive. Must be positive. Must be positive, even though 0 can be really positive or negative. It has no significance. This must be positive, but it's not. It's negative. Like, what do I do? Well, here's the thing. There's nothing that you can put in for x here. Nothing. Nada. That you can put in there that will make this a negative 5. Okay, because in the end, whatever you work out here, you're putting bars around it, and it's going to make it positive. Okay, and positives cannot be negatives. So this is cool. All you got to do is write no solution, and you are done, and there is no graph. So you can be like, go away, sucker. Okay, and it's done. Except I went too fast. Still too fast. Okay, so here's like what I like to do. Well, not this one yet. I jumped too fast. All right, next group, these are almost the same thing. It says solve each equation and then graph, and you're like, well, the only thing that looks different is I got this new piece that is included here. And another one right here. What does that mean? Do I just combine the 7 and the negative 9 and the negative 6 and the 9, or the 9 and the negative 10? And the answer is a big fat no, you don't do that, okay? Let me show you what you do. And it goes like this. Your goal is to do what you see right here. It says the absolute value must be isolated. What's isolated mean? It means it's got to be by itself, okay, in order to finish your problem. All right, so what I'm going to do is I'm going to get rid of the subtract 10. I don't want it there. I want it to look like a problem like I had on the other slide. So the opposite of subtract 10 is to add 10. Okay, so these are going to go away. And then I'll do this math. Negative 4 plus 10 is 6. Okay, now again, some people are like, I thought you just said if this thing was a negative, you just said no solution. And that's true, but that's when it's equal to the bars by themselves. Like if this were a negative, you could stop. Okay, but that subtract 10 is a game changer. And you have to get rid of that first. And then after you get rid of it, you can make that judgment. Okay, all right, so 3x plus 9 is equal to 6, and then 3x plus 9 is also equal to negative 6. Notice the only sign that I'm changing is the part that's equal to the answer. All right, so this is a little bit more elaborate compared to the other ones. I'll still treat it the same way. I'll subtract 9 to both sides. And 6 minus 9 is negative 3. And if you're like, wow, how do you do that? Use the calculator. But the idea is if you weren't sure, you could always do this. Just say, hey, you know what? Here's 6. When I say subtract 9, I got to go 9 this direction. Okay, so 1, 2, 3, 4, 5, 6. That's where 0 is. There's my 6. 7, 8, 9. That finishes at negative 3. Okay. And then how do you finish this? Well, this is a time sign. The inverse operation of multiplication is division. And that leaves me with a negative divided by a positive is a negative. Similarly, I have this plus 9, so I'm going to subtract 9. That was the same step I had over here. And let's see, a negative plus another negative will give you a third negative, and it's negative 15. Again, if that was confusing, use a graphing calculator and punch those in. And then of course you'll divide. a negative divided by a positive is a negative. Okay, so 0 would be somewhere over here. Negative 1, 2, 3, 4, 5. And you would fill those in accordingly. All right. Hey, let's try another one with another color here. Green. All right, now, again, we're not looking at this whether it's positive or negative yet. We have to decide first what's going on with this plus 9. Okay, I don't like this thing here, so let's get rid of it by subtracting 9. Three minus 9 is negative 6. All right. And so now what I would do is I would take this part here, I would look at it and say, all right, I would have to set it equal to a positive 6 or a negative 6, but it's already negative once we do that first piece. Okay, so I don't look at it from the first step if I have this extra stuff here. I look at it after the absolute value of bars are by themselves. Okay, and since that is a negative, okay, and this has nothing else with it, it is alone, it is isolated, it means you have no solution. Okay. All right, last one. Again, I don't like this subtract 9 here, so let me get rid of it. Let us add 9 to both sides. Okay, so I'll get x plus 7 is equal to 18. And this is in bars. And this is positive. So that's kind of what I needed. Okay, sorry, that can all be like this. It is a positive. So I'll set this equal to 18. And then I'll also set it equal to negative 18. All right, so let me subtract 7. And that gives me, I think, 11. That's just straight up subtraction. And here, same idea as before. That's confusing. Don't worry about it. Just use your graphing calculator. Negative 18 plus a negative 7. The signs are the same, so you're going to add those and then pick the sign of the bigger number. This is bigger, so we'll get negative 25. Now, some of you are like, do I have to draw 25 tick marks to the left? No, I'm counting by 5s. 5, 10, 15, 20, 25. And 11. Okay, so I'm counting by 5s. 5, 10, and 11 is just next to it, so I'll just write it like that with 11 above it. Sorry, that was quick. Okay, hopefully that makes sense. Okay, now here's what I'm going to do. I'm going to give you a mixture of a couple of them. Okay, so here you have some like the first slide and then some like the second slide. Take a second and see if you can do these on your own. Pause this, okay, because I'm going to talk about them in just a minute. But pause it and see if you can do it on your own. If you do these on your own, you're gold. Okay, so pause it, and then when you're done, take your time. Then unpause it, and I'll give you the answers. Okay. Okay, so hopefully you gave these a try on your own. Okay. Again, at any time, if you have to, stop this and relook at it, please don't hesitate to do that. Okay. There's nothing wrong with doing that. And again, I just want to make sure you got it right. All right. So. All right, here was my first step. I had to get rid of this plus 5 here, and I did that. I did that by subtracting 5. 9 minus 5 is 4. And then from here, since that's what my bars are equal to, my absolute value bars are equal to 4 here, I'll set equal to 4 and then negative 4. And then you just solve. 4 plus 2 is 6. And then I have to do the same thing to the other side. And again, negative 4 plus 2 is a negative 2. All right, so 1, 2, 3, 4, 5, 6. And we'll put those in. All right, very good. So let's keep going here. Oh, cruddy, Tom. Hold on. I call myself Tom. So. Positive. Remember, once you get to this spot here, pardon me. Oh, I did that right. Jeez. All right. I cannot afford to start over. so I'm not. That was good. And I'm putting that back. Sorry for the erasing, okay? Again, I have a subtract 2 here. If I go over to where the 2 is, that is the halfway spot. Okay. All right, next one. Notice I didn't have to subtract anything over. I didn't have like this guy here that I had to get rid of. It was just the plain bars. So all you have to do is set it equal to 16 and negative 16. So I will subtract 7 to both sides. And I get 2x is equal to, looks like 9, right? And then I'll divide by 2. Okay, now you can leave it as 9/2, but it's easier to graph if you divide those out. That actually gives you 4.5. Okay. And again, you can do that on a graphing calculator or a calculator, your choice. All right, I will subtract 7. And negative 16 and a negative 7 give you negative 23. Okay, those do divide out. Not cleanly, but it does give you a negative. And how many times is 2 going to 23? 11.5. All right, so some people are like, I don't want to graph these that have fractions that are decimals in it. And I don't blame you. But we'll still do it. Here's 5. So 4.5 is somewhere in between it. And I'm just going to put that above. Okay, and negative 11.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 11. I'll acknowledge that as negative 10. And it's somewhere in between. Cool. All righty, we'll keep going. If that doesn't make sense, again, pause it, look at it again, okay? And see what's up, all right? Again, I have to get this guy by itself. And I don't want to subtract 3 here, so I'm going to add 3. All right, and negative 11 plus 3 is negative 8. And again, taboo. You cannot have absolute value bars set equal to a negative, because anytime you put a number in here, it always makes it positive. And so positives cannot be equal to a negative. These are my favorite. No solution. You're done. Okay. All right, finally, this last one. Again, you can't set them equal to 7 and negative 7. You have to deal with this piece first. Okay, get rid of that, subtract 3. We'll add 3. And so you get 7 plus 3 is 10. Okay, and so I'll set it equal to 10 and negative 10, and we will complete both pieces. Most people are like, can I just do this one? Yeah, but you have to do this one too. Okay, so this is really what I'm testing you on. I know you know this one, all right? But do you know the second piece? Do you know the significance of these bars and what they do to your algebra? Okay, and so this one here that I'm circling is más importante. Okay. All right, so I'm going to cut this in half. 10 minus 3 is 7. And I got a 2x here. And I will divide. And so imagine this. If you had $7 and you had to cut it in half, what would everybody get? Well, $3.50. All right, same thing here. Let's subtract 3 to both sides. And the signs are the same, so you'll add, you'll get negative 13. Okay. And then when you have this 2 here, this is a 2 times x. So you will divide by 2. And that is negative, again, you can do this on a calculator, 6.5. Okay, so here is 0. There's 4, of course. 3.5 is somewhere in between here. So I'm just going to write that in, 3.5. And negative 6.5 is to the left. 1, 2, 3, 4, 5, 6.5. So 6.5 is somewhere in between the 6 and the 7. And again, I want to acknowledge it. So I'll say it's negative 6.5. Sorry, that was fast. All right, any questions on those? This is just a summary, this part right here, this slide, of the first 2. All right, so if you got this, that's a mixture of them. Sometimes you don't have to add that first piece like here. Okay, sometimes you do. Okay, add or subtract something to break it down so that you just have the bars by itself. Okay, here's what we got. It says, in a cheerleading competition, the maximum length of a routine is 4 minutes. Sorry, minimum is 4 minutes. Okay, it says the maximum is 5 minutes. Okay, write an absolute value equation that represents the minimum and the maximum. All right, so here's what you're going to do. Easy. First of all, put your bars in, and always write x minus. Okay. And here's what you're going to do. I'm going to draw this. It sometimes makes it a little bit easier. And I know the minimum has to be 4. The maximum has to be 5. I told you, I'm going to tell you, find the halfway spot. Okay, halfway. Now, if you think about $4 and you think about $5, even though we're not really talking about dollars here, what's the halfway spot? Well, it's 4.5. Okay, and remember what I told you from the very beginning. I said it wasn't important then, but it is now. This 4.5 is actually the number, the halfway spot that goes right here. Okay, the halfway spot is right in the middle. Okay, and then what do you put on the outside? Well, it's the distance. How far is 4.5 from 4, and how far is 4.5 from 5? It's a half, or 0.5. So that's what you see set equal to. Okay, and that's it. You don't really have to do the math. If you want to check to see if it's right, just do it. Set this equal to 0.5. And set it equal to negative 0.5. Because that's how we do these, right? Okay, and what would you do? Well, you would add 4.5. Okay, I'm going to put a little 0. So I can fix that. See if I can fix it without erasing the whole stupid thing. Darn it. Okay, here's what I had. X minus 4.5 equals a half. Okay, and so I said, sorry guys, you'll have to rewind it if you want to write it down. Okay, if you add 4.5 to both sides, all I want to do is get rid of the dot, which was behind here. If you have 0.5 added to 4.5, that's actually 5. And if you set it also equal to the negative, which is what we do, a negative 0.5, you get a 4. And so those are your two answers, okay? It's just your way of checking, okay? So again, this is your halfway spot. If you graph it, it's easy to see what the halfway spot is, okay? And then this is the distance from the halfway to the end. I'll just say half to an endpoint in either direction, okay? All right, try this one, okay? Hit pause, give it a second. It says, find a poetry, there's a poetry contest. Has to be a minimum of 16 lines. That's a lot of lines for a poem. Okay, so 16, I'm afraid to erase, all the way to 32. Okay, and again, you have x minus something equals an answer. Okay, figure out what goes here, figure out what goes here. I'm going to give you a minute, all right? Pause it, give you a minute, and then we'll fill it in, okay? All right, so halfway spot. If you're not really sure how to find the halfway, here's what you do, little trick. Just add them, add the two endpoints, and then always divide by 2. Okay, so this will give you 48 divided by 2, which is 24. Sometimes it's easy to figure out in your head, you know, because the numbers aren't too big, but this one is not. Okay, so this is 24, not as easy to do. And then you have to ask yourself, how far is 24 from 32? And it is 8. Okay, so again, halfway spot. If you're not sure how to find the halfway spot, Again, there's your 16, there's your 32, add them and divide by 2. Okay. If you want to do a little test to see that it works, then you can, but you don't have to. Okay. All right. If there's no questions on this, then we go to one more final part. And you're looking at this, you're like, oh, this looks impossible. And it's not that bad. Okay. It's like solving equations with x's on both sides. No big deal. So here's what you do. You're going to set this equal to x, just like you did before. And then you're going to set this 3x minus 4 equal to the opposite of this, so negative x. Okay. And so when I do these problems, we have to get all the x's on one side. It may not make sense to put all the x's on the left because I have too much stuff there. Okay, so let's do this. Let's move all the x's to this side. Okay, so I will subtract the 3x. Okay, these will go away. You got negative 4 is equal to 1x minus 3x is negative 2x. All right, and then to divide by the opposite of multiplication, so negative 2, negative 2. Two negatives equal a positive. Okay. Same thing over here. Let's subtract the 3x to both sides. And 1x minus 3x is negative 4x. And of course, divide. Okay. And that is it. Okay. I know you're looking at this thinking, these feel harder. They're barely harder. Okay. It's still the same idea. Take this equal to the back piece. And then take this guy here, again, the front piece here, set it equal to the negative back piece, whatever that may be. Okay. All right, so same idea. Let me do this in a different color here. I'm going to set this front piece, x plus 8, equal to 2x plus 1. And then I'm also going to set this x plus 8 equal to the opposite of this. Now, how do you write the opposite of that? You just put a negative out front. Okay? You're like, that doesn't look cool. Maybe not, but we'll deal with that in a second. Okay? Let's think about this from our quiz that you guys did a pretty good job on. How do we solve for x? Okay? Let's commit to x's on either side. It doesn't matter. You can put them over here. It may be easier to put them over here. It makes things positive if you want. So watch this. If I do a minus x here, I have to put an x on this side as well. So I'm going to put it underneath the 2x. Okay, so those will go away. And I got an 8 is equal to, because that guy comes down, well, 2x minus 1x is 1x. Okay, plus 1. And then, of course, you'll have to get rid of this, add 1 here by subtracting. Okay, and we are now halfway done. Okay. Like, dang, that's a lot of work for being halfway done. It is, okay, but I know you know how to do these because you did well on your quiz. Now, what does this mean? Well, it has a negative out front. All it means is you rewrite this whole piece here, but change the signs, okay? And not just one sign, change the sign out in front of the 2x as well, okay? So negative 2x minus 1, okay? Now, you can move all the x's to the side like we did before, or you can reverse. It doesn't really matter. But I'm going to add a 2x to both sides. Okay, and so 1x plus 2x is 3x. And you got a negative 1 here. Let's, again, when you put the 2x's down, make sure you put it underneath the other x, okay? Don't put it underneath the 8 because you can't subtract 8's and x's, okay? All right, and then what I gotta do is get x by itself. So the opposite operation of add 8 is to subtract 8. Okay, and then I'll divide. 9 divided by 3 is 3, and you got to pick the sign of the bigger number. Okay. All right, we will do one more of these. Let's just do this one. Okay. These are all the same. So I think if you got the idea of one or two, we don't need to spend time doing a ton of them, okay? So last one that we'll do together before we go to the next slide. 3 times x minus 4 is equal to 2x plus 5. And then really here's the second and most important thing. Let's actually be a parenthesis now. You have 3 times x minus 4 is equal to negative 2x plus 5. Okay, we'll talk about this guy in a second, that negative sign. But what does this 3 mean? Well, yeah, it means distribute. Darn it. Oh, this is stopping. I don't want to stop it. Keep. Okay. All right. You're kind of hoping that would be it. And you're like, dang, if he was done, he's probably not going to start all over and be it. That would be it. He'd probably stop there. I found it. All right. So again, I'm going to write this out. This is 3x minus 12. All right. And you have to do the negative version of it too. This is the more important piece. I know you know how to do that. We've done that. We did that last couple sections. This is new. Okay. And again, you do that when you have the bars. Okay. So this gives you negative 2x, and a negative times a negative is a positive. Basically means you change the signs of whatever you see in these two spots. Okay. And so, again, I'll put all the x's on one side. They could be on the right side or on the left. It doesn't matter, but I'm going to move the x's, I think, over here, which means I have to get rid of my subtract 2x, and I'll do that by adding. 3 plus 2 is 5. Okay, bring down your subtract 12, and this just drops down to. I didn't mean to do both problems at once, but I'll do that over here too. I'll do that yet. Subtract 2x. Gotcha, I can erase. I know you're daring me. That's a different eraser. I don't know why. Okay, so subtracting 2x, these go away, you'll get x minus 12 equals 5. And last step, let's add 12 both sides. I'm hoping I didn't do that too fast. Okay, hopefully that's okay. 2 steps here. We'll always do the add and subtract first. Let's add 12 to both sides. And negative 5 plus 12 is 7. If you're not confident with that, use a graphing calculator or a regular calculator. And then remember, there's a time sign here, so we will do the opposite operation, which is to divide. Okay. All right. So I know you know how to do these. Okay, I didn't do this last one because I know you're sick of doing them. But let's make sure we got this. Okay. And here's the last step. Okay. It says solve each equation and then check your solution. Okay. Now you're like, what does it mean to check our solution? It just means you got to plug the numbers back in to see if it works, okay? So let's do this. Should we start with, this one's not that bad. Let's do what we did before. Let's set this equal to 4x, and then we'll also see it set equal to a negative 4x. All right, so 2 steps. Let's get all the x's on this side. Okay. That way there's fewer work for, well, a little bit less work for us to do. The opposite of add 2x is to subtract 2x. Okay, so 12 is equal to 4 minus 2 is 2. And then you will divide. 12 divided by 2 is 6. Okay, same thing here. Let's divide by 2x, or subtract 2x, sorry. Get all the x's on this side. 12 comes down. Negative 4, negative 2 is negative 6. All right. And again, if we're multiplying by a negative 6 to this x, we will now divide. All right, now here's what they want you to do. And you're like, kind of done doing these. Okay, what you gotta do is you gotta plug these in just to make sure it works. You're like, what does that mean to work? Well, what I'm going to do is I'm going to rewrite this 2x plus 12 equals 4x. But any place I have an x, I'm going to replace it with a 6. Okay, so this becomes 2 times 6 plus 12 equals 4 times 6. And we're going to see if when I plug in 6, does it work? Okay, so I'll plug in a 6 here and a 6 here. The part on the right is a little easier. 4 times 6 is 24. And let's see, this is 2 times 6, which is 12. This is already a 12. And so 24 is equal to 24. Okay, so 6 is legit. Now, if I plug in -2, does that also work? Okay, so I'm going to do the same thing. I'm going to replace my x, sorry, it's a bar, with a -2. Okay, so let's replace this with -2, -2. So this will give me -4 plus 12 equals -8. And -4 plus 12 is -8. But when you take the absolute value of -8, what happens? It becomes a positive 8. And that is not equal to -8. Okay, so this is a crazy situation here. We got this x here on the back, and when I test it, you find out that it does not work. Okay, it's not valid in the end. So in the end, I'm going to say this is called an extraneous value. Okay, and you can see this word up here. I'm not going to make you write it or even say it. It's just awkward. But that's what this guy is right here. Okay, it's when you get an answer and it doesn't match up. Okay, you did the math right, but when you plug it back in, it gives you something that's not true. Okay, so we will stop there and we'll be done. Okay, so the only answer that works is 6. Why is this important? Well, one, we want to make sure that both of our answers work, but two, sometimes you'll take a test, like an ACT test or an SAT test or a final exam, and it's all multiple choice. And you know what they'll do? They'll do this. They'll be punks. They'll say, hey, here are your answers. The answer is 6 or -2 or 6 and -2. And what does everybody do? Like, oh, cool, it's this. When deep down, the only answer that was right is 6. And you show that you know exactly what you're doing, but if you don't test it, you get that wrong. Not done. Okay, so let's do this one. We'll do x plus 5 is equal to x plus 11. Okay, and then we'll do the same thing over here. We'll do x plus 5 is equal to negative x plus 11. Running out of room. Let's see. All right, and let's just start this off. Let's subtract x to both sides. And you get 5 is equal to 11. Is 5? Oh, cruddy. Yes, I want to keep it. And no, I'm not done. Let's scroll down. This is our last slide, by the way. Sorry. All right, so does 5 equal 11? No, it does not. So this is a weird one where you're done. Okay, the x's canceled out. Some of you did this really well on your test. You're like, hey, x's went away. These are not equal to each other, and you stopped. Make sure you just say no solution. Okay. All right, let's do one more. I'm thinking that this one looks like an easy one. Okay, x plus 6 is equal to 2x, and of course, x plus 6 is equal to -2x. We'll test it. We'll get the answers for each, and then we'll see if we are correct with our answers. Okay? Now, do I want to subtract 6 to both sides? Well, probably not, because the 6 won't cancel out with anything on the side over here with an x with it. So let's do the reverse. Let's get all the x's over here, and we'll do that by subtracting. Okay, so 2x minus 1x is 1x. And same thing here. Let me subtract an x over here. You do that so those will go away. Again, it makes sense to put all the x's over here and all the numbers over there so that I can do this in fewer steps. -2 minus 1x is -3x. And again, if you're not sure what -2 minus 1 is, just do it in a calculator. Okay. -2, subtract 1. Subtract 1 means go to the left. It's -3. There you go. All right, so now we'll divide. And a positive divided by a negative is a negative. All right. Now, this is the last one we're going to do, but I am going to check it. I'm going to plug in 6 back into the original. So 6 plus 6 equals 2 times 6. And again, put the bars in because that's what my formula has. 6 plus 6 is 12. And the absolute value of 12 is also 12. Okay. Now, does it work when you do -2? I don't know. And let's see. So -2 plus 6 is 4. And absolute value is 4. Okay. And then 2 times -2 is -4. And no, those are not equal. So my only answer is this dude right there. Okay. This will not be an answer. Some people say, do I always get one answer that works and one that's not? It happened in this case. It happened in the first example, but not always. Sometimes both of them work, and that's cool. All right. But not always. It just depends on the specific problem. Okay. We don't have to do this one. If you were to do it, you would get another solution, I believe. No solution. So be careful of those. Those seem to occur often. Oh, you know what? Let's try it. Yes, these do go away. Okay, and -4 does not equal +4. Sorry, -2 does not equal +4. Okay. Now, if I did the same thing for the second part, 5x minus 2, set it equal to the opposite, -5x plus 4. It actually gives us a little bit more math. And that's -5x. And remember the negative, what it does is it changes both signs. Okay, I don't need that. Okay, so what does that mean? Let's move all the x's to one side. And in this case, I will move them all to this side over here. So let us add a 5x. And if I add a 5x, I have to put another 5x over here. Okay, so that gives me 10x minus 2 is equal to -4. All right, and if you add 2 to both sides, you get 10x is equal to -2. And then the opposites of multiplication is division. And a positive divided by a negative is a negative. It's -1/5 if you reduce that, or 0.2. All right. And I don't know what's going to happen here. If I plug in 0.2 here, 5 times 0.2 minus 2, is that the same thing as 5 times 0.2 plus 4? I don't know. This gives me 1 plus 4, which is 5. And this gives me 1 minus 2, which is -1. And those are not the same. So this one has no solutions, just as we expected. Okay? All right. I think that is all I have. Finally, we get to a black screen where I say, you know what? I don't have to go back and write stuff in, but I want to thank you for your patience and your attention on this. All right. You have like 12 problems like we had before. I don't even think that many. And give it a shot. Show your work, just like I did in this paper on this video. And make sure you submit that under 1.4. Okay. I need your note piece, okay, but don't do the notes part until the end with respect to submitting those, okay? All right, and further, if you have any questions on that, you let me know, and I will be happy to help you out, okay? I will talk to you soon.